Okay, guys, so for today, we are looking at the last part of our 3.0 for the rate of change unit, and we are looking at the rate of change from a situation. Okay, so slope or rate of change, right? They mean the same thing. They're represented by the letter M. Okay, and we can find it by looking for the change in y over the change in x. Change in y over the change in x. And that, of course, we can find the change in y by taking y2 minus y1. Okay, and we put it over x2 minus x1. Remember, if we want to find the change in something, we subtract it, right? So that's why we're finding the difference of these two values. Okay, now this should look very familiar to us in comparison to our lesson previously on the rate of change from two ordered pairs. Okay, this should look really, really similar to us because it's the exact same formula for the slope or rate of change. Okay, so when we calculate the rate of change from two ordered pairs, right, we use our formula that we just found. M equals y2 minus y1 over x2 minus x1. Now we're just going to substitute our values, right? Here's my y2, 3. Here's my y1, the number 1, okay, 3 minus 1, over my x2, 8, minus my x1, 5. 3 minus 1 over 8 minus 5. Of course, 3 minus 1 is 2, and 8 minus 5 is 3, leaving us with a slope of 2/3, 2 over 3. So my slope here would be 2 over 3. Okay, looking at this one, I'm going to use the same formula, okay? My y2 is -5. -5 minus my y1, which is 4. -5 minus 4. And then 6 minus my x1, which is -6. 6 minus -6, okay? We simplify this. -5 minus 4 is -9. And 6 minus a -6. Remember, we see two double negative signs right here. We can add instead. We would get -9 over 12. Now, again, when we get slopes like this, guys, we have to make sure that we're checking it and simplifying it as much as we can, okay? So -9 over 12 can be reduced, and we can reduce that to -3 over 4. Okay, so my final slope for this set of ordered pairs here is -3 over 4. Okay, so my rate of change from a situation, we will write the information given as two ordered pairs. Okay, that's why we did those warm-ups with the ordered pairs there. Okay, so we remember how to do that and get used to doing that. Time will usually be my x value in those ordered pairs. So remember, our ordered pairs are given in x comma y in parentheses. Parenthesis x comma y close parenthesis. Okay, if you have time in your problems, that will be your x value. Whatever quantity is tied into whatever time we're using, whether it's months, seconds, minutes, days, years, okay, that'll end up being your y value. But whichever one is representing time will be our x, okay? And then we'll just calculate the slope by using that same formula we just used on the previous two problems. Okay, so let's look at an example. Jasmine started a savings account. Sorry, guys. After 4 weeks, she had $570, and after 10 weeks, she had $725. What is the rate of change of money in her savings account per week? Okay, so there's a lot to unpack here. Okay, after 4 weeks, she had $570. So in this first part of information we're given, we know after 4 weeks, she had $570. Well, 4 weeks, a big red flag should be blinking at me right now because 4 weeks, that's time. Okay, so that'll be my X value. 4 is my X value because 4 weeks is time. It's representing time, okay? $570, that will be my Y, okay? So the second chunk of information is after 10 weeks, she had $725, okay? Again, 10 weeks, that's time. Weeks is an amount of time, okay? So 10 will be my X value and 725 my Y, okay? Now I have two ordered pairs. Now I can plug them into my formula I've been using, y2 minus y1 over x2 minus x1, okay? 725 minus 570 over 10 minus 4, okay? Once we do the math on that, we get 155 over 6. So what this is here is this, right, this slope that we just found is telling me that Jasmine has, the rate of change of money in her savings account, okay, would be $155 in 6 weeks. But I want to know what the rate of change of money in her savings account per week is. So I would just divide 155 by 6, and I would get about $25.83 per week. Okay, so we know how to do this part right here when it comes to putting stuff into ordered pairs and finding the rate of change of two ordered pairs, okay? This part up here is where it can get tricky. Okay, we need to be able to chunk our information and find out which part is important and what I'm looking for. Okay, remember, time is always my x value, or usually, I should say, my x value. Okay, for number 2, at 8 a.m. on October 6th, the temperature in Dickinson was 35 degrees. By noon, the temperature was 43 degrees. What is the rate of change in temperature? Okay, so here it's a little tricky because we have 8 a.m., which is a time, right? That's a time of day. We have October 6th, which is a date, which also is a time, and then a temperature. So which time do I use? And something I want to tell you guys is we need to get in the habit of being able to identify what we're looking at as far as, the important information in situational problems, because certain tests like the ACT and SAT will throw information at you that actually doesn't matter. Does it matter that it was on October 6th? We're trying to find the rate of change in temperature of that day. Okay, so it really doesn't matter what day it is. It matters at 8 a.m., the temperature was 35 degrees. Okay, so 8 a.m. would be my X because that's a time, and 35 would be my Y. Okay, for the second one, by noon, the temperature was 43. Well, noon, hopefully we all know, is 12. That would be my X, and 43 would be my Y. Okay, now we're left with 2 ordered pairs, and hey, guess what? I know how to find the rate of change of this. I subtract my Y's, I subtract my X's, and I find my rate of change, okay? So I would take 43 minus 35 over 12 minus 8, okay? And 43 minus 35 is 8, and 12 minus 8 is 4, okay? And we're left with a slope of 8 over 4. Well, I can reduce this. 8 divided by 4 is just 2. So the rate of change of the temperature for that day would be 2 degrees Fahrenheit per hour, okay? 2 degrees Fahrenheit per hour, okay? So again, the toughest part of these situational parts, guys, I think is finding the information that's actually being used and being able to put that together. Remember, time is always usually represented by your X value in your ordered pair. Okay, don't forget that step, it's important. Okay, and that is it for the last section of the 3.0.